everybody, welcome to another video. Hope you're ready to flex those brain muscles. Today we're going to talk about fractional exponents. We're going to do some examples. This is kind of where we concluded in the last episode. We just finished a two-part series of exponent rules. So if you haven't watched that, click up here. But at this point we're assuming we're up to date on these. And this is kind of where we left off when we were talking about fractional exponents. We came to this formula. So we're going to use this and we're going to solve a bunch of these and just get some practice. So let's just go right into it. We had this example in the last video. We're just going to kind of warm up a little. And we said that we could write this as, let's see, square root of 4 to the third power. And we could have also wrote it as 4 cubed square root. Either way, but this way is actually a little bit easier if you think about it. So in this case, we have 2 cubed, which is going to give us that 8. And this is the example we had, again, in the last video. So let's see, 81 to the 1/2 power. Well, we know that 1/2 is just square root, right? The 1 is what goes here in the power. The 1 goes there. The numerator always goes here. The denominator is always here. But in this case, both of these are invisible. Invisible 1 there, invisible 2 here. So we just have square root of 81, and this is the principal root, so that's just going to give us a positive 9. All right, so in these two examples, we have fractional exponents, but we also have negative exponents. So we're combining two of these ideas, but don't panic. That's why these are good examples to do to get some practice. So let's go ahead and start. The first thing I do when I see negative exponents is I get rid of the negative exponents. So you simply just take the reciprocal of this and make the exponent a positive. It's that simple. And technically what this looks like according to our formula, I'm going to show you a little shortcut right here. Technically what this looks like according to our formula is we have something to the negative, so we do 1 over that to the positive. But when it's a fraction like this, it always just ends up simplifying, right? I'll put it equals. This equals 16 to the 1/4, right? 1 over 1 divided by 1 over 16. You flip this and multiply. That's how you divide fractions. Flip the bottom fraction and multiply, and you're left with this. But that's always how it works when you have some fraction like that to a negative power. You can flip it and make the power positive and vice versa, positive to negative. So 16 to the 1/4 power is just the 4th root of 16. So what do I multiply by itself 4 times to get 16? 2, right? 2, 4, 8, 16. Boom. All right, let's do this one. Same process. First thing I'm going to do, take the reciprocal of this. So it's going to be 1 over 4. Let's see, 1 over 4 to the positive 5 over 2. All right. And now this ain't too bad, right? Now I know what to do. I can rewrite this using one of these formulas. And just a good general rule is I always do the square root inside and on the outside, or whatever root it is. And then on the outside, I do the power. So basically the denominator part is what I do first, because this usually makes it easier to work out. But every example is different. But in this case, like, think if I had done it the other way around. I got to do 4 to the 5th power, and then I got to find the square root of that. It makes more sense to go the other way when I can go down to 2. And then, so this is going to end up being what? 1 over 2 to the 5th, which is 1 over 32, right? So it usually makes sense to do whatever the root is first, or at least try to. And if you absolutely can't, then do it the other way. But because the point of this is make it simpler. So, yeah. Okay, last 2 examples here. And this one we got a good example because we have a negative base, and we haven't seen that yet. So, what does that mean? First of all, it's only possible because this denominator is an odd number, right? If this denominator was even, and I tried to take something like this with a negative base, it wouldn't be a real number. It'd be a complex number or imaginary number, because you can't take an even root of a negative, right? So this can only work because this is odd, so I know this can work. And I'm still going to do that same process. I have a negative exponent, so I'm going to get rid of the negative exponent. I'm going to do 1 over... So I'm going to rewrite this as 1 over negative 32 to the 3/5. Right? And now I can do my same properties, let's see, I can use my same rules. 3/5 power, that's a lot like what? What is that like? Let's see, 1 over, what root am I taking? Negative 32, and that's the 5th root of negative 32. And then I'm going to cube it. I'm doing the root first. 5th root of negative 32. What do I multiply by itself 5 times to get negative 32? I think negative 2 will work. So negative 2 cubed, and that's in the denominator. And negative 2 cubed is just negative 8. So I'm left with 1 over negative 8. 1 over negative 8. And that's the final answer for that. So yeah, just pay close attention. Go one step at a time. And we'll go ahead and do this last example. 8 over 27 to the negative 2/3. So again, same thing. And I have a fraction in here, so I can use my shortcut. I can simply just flip the fraction and make this a positive. And now what? Now I distribute this to the top and bottom, right? Because if there's an exponent here and this whole thing is in parentheses and it's a quotient, this distributes. That's how I expand this power. So 27 to the 2/3 over 8 to the 2/3. Now what does this equal? I'm going to rewrite this as the cube root of 27 squared. So first I'm going to do that cube root of 27, and I'm going to square that, and that's going to be on top, and the bottom is going to be the same thing, cube root of 8, and that whole thing is squared. So what does this equal? Cube root of 27, what do I multiply by itself 3 times to get 27? I believe that is 3. 3 times 3 is 9, 3 is 27, yeah. So 3 squared is on top. Now bottom is, what do I multiply by itself 3 times to get 8? That's just 2 squared, right? So I'm left with what? 9 over 4. And that is my final answer. And with this one, I was left with 1 over... And again, that negative can be at the top, it can be out in front, it can be at the bottom. It doesn't really matter. If you'd rather see that negative up here, negative 1/8, then that's fine too. All right, hopefully those are some good examples. If you have any questions, leave them below, comments, suggestions, anything like that. If you enjoyed the video, hit like button, and if you want to support me, hit subscribe. Thank you so much for watching. Keep making those brain gains, study hard, do a ton of practice problems, and I'll see you next time.